Hello, why do some production lines produce perfectly straight profiles, while on others the profile begins to twist or bend to the side? The answer lies in the details of the equipment design. Watch this video until the end to learn all the key factors. Today's review is dedicated to a production line for closed-section lamellas. These lamellas are usually made from metal with a polymer coating with a thickness of 0.4 to 0.7 millimeters. Thanks to the closed shape, the profile looks aesthetically pleasing from both sides and is widely used in modern fencing systems. Production lines for closed-section lamellas with edge rolling of the flanges are quite complex, both in terms of roll forming and cutting the finished profile to length. The problem is that when forming a closed profile, residual stresses appear in the metal. If the line is designed incorrectly, these stresses can lead to camber or twisting of the profile after it exits the roll-forming mill. To achieve stable product geometry, several critical factors must be considered in the line design. The first factor is the rigidity of the roll-forming mill. The mill frame must have high torsional rigidity. If the frame lacks stiffness, strong vibrations occur during the forming process, making the roll-forming process unstable. The second factor is the number of forming stands. To form a closed-section lamella, more than 20 forming stands are usually required. If there are fewer stands, the metal bends too aggressively. This creates internal stresses in the profile that later appear in the finished product. Subscribe to the channel to learn more about roll forming, cutting, and stamping of sheet metal. The third important factor is the profile cutting technology. When the profile acquires a closed shape, conventional cutting can cause deformation. That is why on such lines a pilot hole is punched in the metal strip before the profile is formed. Once the profile is formed, this hole becomes the entry point for the upper blade of the flying shear, allowing the cut to be made without deforming the product and with high precision. The fourth factor is the torque transmission system. On high-quality lines, rotation is transmitted through gear drives or gearboxes on each forming stand. This minimizes backlash in the transmission system and ensures stable synchronization of the entire line, as well as accurate positioning of the metal before cutting to length. During profile cutting, the feed accuracy must not exceed plus or minus 0.2 millimeters. For this purpose, a position control system for the pilot hole and synchronization of the flying shear is used. It is the combination of these engineering solutions that determines whether the line will produce a stable and geometrically accurate profile or whether problems will start appearing during operation. If you are planning to launch or modernize a production line, you can contact us. We will help evaluate your requirements, compare different equipment configurations, and select the optimal solution for your production volume, available space, and budget.